G'day everyone, Mike here, welcome back to the channel. In this video we'll be going through day 2 of OpenAI's sort of 12 days of announcements, and this one's going to be reinforcement fine-tuning. So I'm going to straight up and say that my work does not require a lot of these big data sets and analysis on such large data sets, but I thought this is a really interesting feature that they are providing for us in addition to their sort of standard models, and so I thought it'd be worthwhile quickly covering it for those who are interested. So first of all, reinforcement fine-tuning, it's not quite a brand new model. It's taking one of their existing models and just fine-tuning it so that it works on your particular data set. But they did emphasize that it's not quite like standard fine-tuning, where it focuses on actually teaching the models to reason in new ways rather than just simply looking at patterns. So you can get sort of over-correlation where it's like you get really good training from the training data set and then you get to the validation data set and it performs really bad. They are promising that it recognizes sort of general patterns rather than specifics for each training data set, and so it's meant to perform a lot better in that regard. So it's trained using reinforcement learning, and it's to reinforce the correct reasoning paths and to penalize incorrect ones. So kind of like if you are teaching someone something new, it's very similar to that. And apparently, so this is the part that really surprised me, you can have significant learning even after a few dozen examples. A few dozen examples. Now, that is not a lot of examples at all. Usually if you need to fine-tune something, even if it's just minutely fine-tune something, you need hundreds or even thousands of samples. Here it's just a few dozens. That's incredible. So that will be really good if you're tight with the data that you're collecting. You can still get some fine-tuning performance out of it. And of course, the application is always scientific research, healthcare. They did also mention legal and finance as well. Anything that has to do with big data sets and analytics and things like that, I think will definitely benefit from this feature. So in terms of the actual data processing, so it does get a bit technical. So in terms of the actual data that we're presenting to the model, it must be in JSONL files. So it's a rather standard generic, and you could probably write like a Python script to automate a lot of that as well. The grading mechanism, they introduced the concept of a grader, and they pretty much give a score in the range of 0 to 1. So 0 would mean that the model was completely incorrect, was nowhere near the correct answer, and 1 would be perfectly correct. They got every aspect of the answer correctly. And you can also award partial credit as well. If the model got most of the answer, it might get like a 0.7. If it sort of got a little bit of the answer, could get like a 0.3, things like that. And that's kind of what they're going to be using to grade the model as it's being fine-tuned. And they also did mention they're going to provide a bunch of different graders as well for various different applications. So I'd be interested to see what kind of graders could be useful for specific applications. Try out a bunch. They did reassure us that they pretty much have a grader for every type of application, but we'll see about that. But I'm sure they have a variety, and it probably covers most of the applications out there. And finally, they did mention some sort of performance metrics that they have sort of displayed along with this sort of fine-tuning process. So they have the top accuracy, the top 5 accuracy. They also compared their baseline O1 mini against their fine-tune one, and it said it improved from 17% to 31%. And yeah, they further emphasized that it showed significant improvements in generalization, which is really good because when you're fine-tuning a model, you want more generalization. You want more, it's fine-tuned to your data set, but it's picking up more general patterns rather than very specific data set related patterns. So that's very interesting to see, and they do have plans to expand their future RFT program, so their future reinforcement fine-tuning program, which is really good because, again, with any of these OpenAI models or processes or features, their first releases is always the worst that it can ever be. They always get better. Like, think of the original ChatGPT, just their natural language based model. And now compare it to what we have now with ChatGPT 4.0 and 0.1 and things like that. It looks really promising. So yeah, I'd be interested to test out some of this. I'd probably make up some small data sets. I think I used to do a bit of machine learning during some of the university courses. I'll see if we can find some data sets that might be applicable for this. But yeah, let me know if you'd be interested to see any of that. I'll be very interested to test some of these claims out. But yeah, anyway, that's it for this video. As I said, not a super long video, just a quick one just to cover RFT. Thank you very much for watching. And oh yeah, if you did like the video, please like and subscribe. Helps me out a lot. And I'll see you in the next video. Peace.